Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our third problem of fluid mechanics. Okay? Fluid mechanics, problem number 3. First, we come towards statement. On a part-time job, you are asked to bring a cylindrical iron rod of length 85.8 centimeter and diameter 2.85 centimeter from a storage room to a machinist. Will you need a cart within bracket to answer? Calculate the weight of the rod. Okay, hint is given that we have to find out weight of the rod, and if weight is less, then no need for cart, and if weight becomes very large, then definitely we will need cart. Okay. Moreover, dear students, here length and diameter both are given in centimeter, but we are following a MKS system, so we will have to convert these two quantities in centimeter into meter. Okay, when we convert centimeter into meter, we divide by 100. When we convert meter into centimeter, we multiply with 100. Okay. Now let us come towards the solution of the problem. Dear students, earlier part of this solution is quite similar to previous two problems which we have already uploaded on our channel. Okay. Solution: density is mass per unit volume. If a mass m of homogeneous material has volume V, its density rho is given by rho equal to m over V, equation 1. Okay, this rho RHO rho. Okay, this symbol is denoted by rho. This is not P. Okay, density is denoted by rho, which is similar to P. Okay, we know from table of densities that density of iron is 7.86 into 10 raised to the power 3 kilogram per meter cube. Okay, dear students, here if we do not write into 10 raised to the power 3, then we will write 7860 kilogram per meter cube. Okay, we know from table of densities that density of iron is 7860 kilogram per meter cube. Now let us first see the table to make our concept clear. Okay, then we will come back towards our solution. Okay, this is the table. Okay, densities of some common substances at standard temperature and pressure. Okay, substance density rho in kilogram per meter cube. Then second column. Okay, this table comprises two columns, and density of iron is given at the top of the second column. Okay, iron 7.86 into 10 raised to the power 3 kilogram per meter cube. Okay, in our previous module or previous problem, we were concerned with the density of air, okay, which was 1.29. But in this problem, we are concerned with the density of iron, which is 7.86 into 10 raised to the power 3 kilogram per meter cube. If we do not write 10 raised to the power 3, then we will write it as 7860. Okay. Now we come back towards our, okay, we know from table of densities that density of iron is 7860 kilogram per meter cube. We are given that length of iron rod equal to L equal to 85.8 centimeter, which alternatively becomes equal to 0.858 meter. Okay, as I have already described that we are following MKR system in which we take length in meters instead of centimeter. Okay, here there is no need to write it as L. It is just for our convenience, because in the next part of this solution we will come towards the formula for volume, in which length will be used and we will use L in that formula. Okay, this is just due to this reason that we have denoted 85.8 centimeter by L. Okay, diameter of cylindrical iron rod equal to D equal to 2.85 centimeter equal to 0.0285 meter. Again, the same reason that we are following MK system and length is taken in meter instead of centimeter, so we have converted both quantities from centimeter into meter. Okay, we have denoted length by L and diameter by D. While it is not necessary, it is just for our convenience. Now we come towards the radius of cylindrical iron rod equal to R. We know that radius is always half of the diameter, so R will be equal to D by 2 equal to 0.0285 meter divided by 2, which alternatively becomes equal to 0.01425 meter. Okay, LDM. Here we are not concerned with D, we are concerned only with R, but without D we cannot come to R. Okay, D is given and we have calculated R by dividing D by 2. Okay, so LDR, three quantities are given. Rearranging equation 1. Okay, rearranging equation was 1 as M equal to rho V. When we will keep M on one side, then volume V will be multiplied with the density rho. Rearranging equation 1 as M equal to rho V and using volume equal to pi R square L. Okay, the value of pi, that is 22 by 7, is taken as 3.14. We have already discussed that decimal representation of pi is non-terminating and non-repeating, but we have restricted this value only up to 2 decimal places. Okay, so in place of pi we have put 3.14. In place of R we have used its value, which is 0.01425 meter, which we have already calculated by dividing given diameter by 2. Okay, then L is again given, which is 0.858 meter. Okay, This alternatively becomes equal to 0.00055 meter cube. Okay, what is this? This is volume, value of V. Okay, we get rearranging equation number 1 as rho as m equal to rho V, and using this formula V equal to this, we get m equal to rho V equal to, here we have used the value of rho, that is 7860 kilogram per meter cube, into value of V, which we have already calculated above by this formula pi r square L. Okay, so m has become equal to 4.323 kilogram. Okay, so we have almost solved our problem. Mass has become equal to 4.323 kilogram. Now we know that W is equal to mg, and we have calculated above mass equal to 4.323 kilogram, and value of g, acceleration due to gravity, is constant 9.8 meter per second square. By putting these two values, we get W equal to 42.36 Newton. Okay, because kilogram meter per second square is equivalent to or equal to Newton. Okay, 1 Newton is equal to 1 kilogram meter per second square. Okay, and this 42.36 Newton alternatively becomes equal to 9.52 pound. Okay, here LB stands for pound. Okay, pound is denoted by LB. Okay, this again alternatively becomes equal to 4.32072 kg kilogram. Okay, that is conversion factor between pound and kilogram. Okay, dear students, here we have calculated mass equal to 4.32, here 4.32. Okay, 4.323, 4.32072, very small or negligible difference. Okay, this difference is negligible, and it can also be rectified if we take the values to exact extent to more decimal places. That is to say, this negligible difference in accuracy has nothing to disturb our solution. Okay, next, dear students, in bracket we have mentioned that because these three dots, okay, these three dots, two in a line and one below, this symbol means because, since. Okay, since or because 1 Newton is equal to 0.224809 pound, or equal to 0.102 kilogram. Okay, from the table of conversion factors we have taken this value. Okay, 3 dot means because. If this dot is above these two dots, then it will be read as therefore. Okay, so 3 dots denote, sometimes denote therefore if this third dot is above these two dots, and if this third dot is below these two dots, then it is read as since or because. Okay, so from the table of conversion factors, 1 Newton is equal to 0.224809 pound, and 1 Newton is also equal to 0.102 kilogram. Okay, we have seen that in both cases m, that is mass and weight, are have become exactly equal. Okay, hence for a rod of length 0.858 meter with diameter 0.0285 meter, there is no need for chord. Okay, dear students, because this length is less than 1 meter. Okay, this is not full meter, this is 0.858 meter, less than 1 meter. And this diameter, even if we take it in centimeter, it will be 2.85 centimeter, that is, it is less than 3 centimeter. Okay, so size is quite small, so no need for chord, and our problem is solved. Now we come towards the reference book from where this problem has been chosen. Okay, reference book is Sears and Zemanski's University Physics with Modern Physics. Its authors are three. Okay, Hugh D. Young, Roger A. Friedman, A. Lewis Ford. Okay, three authors. Its publisher is Pearson, and its 14th edition 2016 or 15th edition 2020 is being followed. And our concerned chapter is chapter number 12 under title Fluid Mechanics. Okay, and this problem is the first exercise of this chapter, that is exercise number 12.1, and this is the end of our module. Okay.